Michaela.
That it lands on red 24 times, blue 15 times, green.
Okay, and which one are we focusing on in our problem? Yep. So we're trying to find the experimental probability of spinning and landing on red, right? So we're going to use this section of our graph. What else do we need to know? Bladen? We need to know how many total times it was spun, okay? So, Kaden, how many times did it actually land on red?
24 times.
Okay? Over our total times that we conducted the experiment, and how many times did we conduct the experiment?
60 times.
60 times, right? What could we have done if our problem didn't tell us how many times it was spun? Emma? You could have added up at all that it landed on, right? Because you only had those 3 options, so that would give you the total number of times spun. But it was nice that they gave us the answer.
Wait, but what if they didn't have either of them? Would we put it over 100?
Well, we wouldn't know the experiment results then, right? Yep. Okay, so can we divide both 24 and 60 by something?
4.
Okay, I heard 4. Anything else?
2.
2. Anything else?
12.
12, okay? You could do all of those. We'll all get the same answer. You just might have to keep reducing. Okay, so 24 divided by 12 is?
12. 2.
2.
Yeah.
And then 60 divided by 12 is?
5.
5. Okay, so that's our fraction. I need to turn that into a decimal. How do I turn that into a decimal?
You 2 divided by 5.
I divide 2 divided by 5. I'm going to show you longhand division. So 2 divided by 5. Can 5 go into 2?
No.
Can 5 go into 20?
Yeah.
How many times?
4.
4.
Done.
4 times 5 is?
20.
Subtract and I get?
0.
Okay, so my decimal, so I have 2/5, I have 4/10, and then I need a percent. Addie, what's my percent?
40%.
40%.
Wait, why would we put the 0? Why would we put the 0? Is it because it's a tight spot?
Yes, because our one spot's a 0, because we couldn't.
Okay.
Okay, so that was our experimental results. Questions on that? Okay, so moving down to example 2, it asked us to compare the experimental probability you found in example 1 to its theoretical probability. Okay, so what are we going to need to know to solve this one? Jaden, what do you think?
Well, the probability of spinning red is 1/3.
Well, that's just the answers from our book, but what are we going to need to know in our story problem to find it?
Oh.
Emma,
There's 3 sections.
why is that important? What? It is important, okay, because if we wanted to draw it out, I have a spinner. We're going to pretend that these sections are equal. My options on my spinner are red, green, and blue, right? So in theory, Kaden with the K,
Yeah.
in theory, how many times should I land on red? How many sections do I have that are red?
1.
Out of how many?
3.
So that's why it's important to know how many sections were in my spinner. Okay, I can take 1 divided by 3 to get my decimal. When I type that in my calculator, what do I get for a decimal rounded to the nearest 100? Bella? 3,300. Because that last 3 is in the hundreds place, but yes, close.
I thought it was 0.
And then can I change that into a percent for me, Maddie? 33%. Okay, was the question asking me to find the theoretical probability?
No.
What did it say to do? Okay,
On the experimental probability.
well, we're in number 2 now.
Oh,
Yeah.
yes.
It asked me to find it?
I mean, well,
Yeah, it asked you to find the experimental probability.
Does it?
Yeah.
What's the wording on the question?
Oh, compare the experiment.
So now we need to compare them. Okay, so this was our theoretical, and we already did our experimental, and we got, I forgot,
No.
2/5, 4/10, and than 40%, right?
Yeah.
So this was my experimental, and this was my theoretical. Which one was greater?
The experimental.
My experimental was greater than my theoretical, correct?
Yeah.
Okay, so that would be my answer. Are they pretty close though?
Yeah.
Why?
Because they're only
How many times did we spin the spinner?
4.
60, right? So is that a pretty good amount of time?
Yeah.
Okay, so that's why they're close. If I would have only spun it like twice, I doubt my theoretical and experimental would be close in percentages.
Yeah, it'd either
Okay.
be 50. They would either have to be 50 or 0.
Okay, what I would like, I'm going to do the next one with you because I think it's kind of confusing the way that they word it.
2 or A?
A and B. Okay, we already did 2. So A, would you read it for me, Addie?
Refer to example 1. The spinner was spun 3 more times and 3 each time. Find the experimental probability of spinning 3.
Okay, so if the spinner was spun 3 more times and all 3 times it landed on green, how many total times did it land on green?
24 times.
Clayton, how'd you do that? Okay, so in our previous results up top, it landed on 21. So 3 more times to that would be 24. Okay, how many times did I spin total now?
63 times.
And how'd you do that?
60
Okay, so originally I spun it 60, but if I spun it 3 more times, I spun it 63 more times. Can I reduce 24 over 63?
Yes.
By what? I really hope you guys are writing this down.
I am now.
What can I divide both the top and the bottom by?
4.
63 is odd.
3.
9.
7.
I think 3 works.
Yeah.
Okay, so 24 divided by 3 is?
8.
Oops. And then 63 divided by 3 is?
21.
21. Because 6 divided by 3 would be 2, 3 divided by 3 would be 1, so 21. Okay? I can type that into my calculator to get my decimal. Berkeley's going to get us the answer.
38.
Good, 38 hundredths. And as a percent, Bella, that would be 38%. So that was got it A.
Now I'm guessing you got it.
Okay, I want you to do B on your own, yes. I helped you out with A.
Wait, so what's our experimental?
Find what the experimental probability of rolling the sum of 9 is. So how many times did we actually roll a sum of 9?
8.
Right here it says 8 times, right? So 8 out of how many times did we roll the dice?
20.
It says 20. Okay. Can that be reduced?
Yes.
By what?
4.
What do you get?
2.
Which is what as a decimal? 4/10, which is the same as 40%. Okay, so that was our experimental probability. Do we have questions on that? Okay. Going over to question 4, it says to compare the experimental probability that we already found to its theoretical probability. And if it's not close, we have to explain a possible reason for discrepancy. Discrepancy means why are they different, okay? So I started to draw a table for you guys. So this would be my options in blue are dice 1. My options for dice 2 are pink. Is that correct?
Yes.
Okay, so for my options, I would have a 1, and I rolled a 1 and then a 1, right? 1 and then a 1. So then this one would be a 1 and then a 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, and so on, right?
Yeah.
And then I could do it across. This would be a 1 and a 2, a 1 and a 3, a 1 and a 4, 1 and a 5, and so on, right? So what would this box down here be, A?
Six and six.
Okay. So, without filling in this chart and going through one by one by one by one, how can I get a sum of 9 when I roll the 2 dice together? 3.
6 and 3.
Yeah, 6 and 3. Because we're not you're multiplying. With sum means to add. So to add them together, I would need a 6 and a 3. I heard that. What else?
5 and 4.
A 5 and a 4. I heard 7 and 2. Is there a 7 on a dice?
Oh, no.
Okay, so that one doesn't work. Is there any other options? What if my what if
and a 1.
Oh, wait.
what?
An 8 and a 1.
Is there an 8 on a dice?
Isn't there 7 on the
Okay, what about a 3 and then a 6? Does that still give me a sum?
Yeah.
It's different because this is my first dice and this is my second dice. First dice, second dice. So then 4 and then 5. So how many different ways do I have an option of getting a sum of 9?
4.
4 out of, how many total options do I have?
A lot. 12.
Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right there.
24.
1, 2, 3. No.
36.
How did you get 36, Emma? Yeah, because if we have 6 options up here and 6 options down here, 6 by 6 is 36. Okay, so I have 36 total options. Can I simplify that?
Yeah.
Divide by 4, and what do you get? Which is the same as? And the same as? Okay, so what was our theoretical? Somebody remind me from the previous problem?
40%.
What?
40%.
Ooh. Oopsies.
What happened?
I don't know. Okay, so anyway, what was our experimental?
40%.
40%, and our theoretical was 11%. So which one's greater?
40.
40%, which goes with which one? Theoretical or experimental?
Experimental.
So our answer would be experimental is greater than theoretical. Why do you think that there was such a discrepancy, or why do you think it was so different? How many times did we roll the dice?
36. 20.
We only rolled the dice 20 times. So is that very many? No, that was less than the number of options we had, right? Because we didn't even hit every single 36 options. So the reason why it was so different was because the number of trials was so few. Okay? Remember, the greater number of trials, the closer and closer it gets to theoretical probability. Okay.